Welcome to EDU World Space.
Let's use a computer algebra system to rewrite this sum. So the first thing I'll do is go to Wolfram and I'll find a different way to express this sum. So I'll have Wolfram tab open and I see that one way. So let me maybe scroll up here to convince you that we have the right formula. So that's the fraction. And now one way to rewrite it is given by this first alternate form. So let's write that out. So we have 1 over n minus 2, n minus 1, n plus 1, n plus 2. Now, a trick here, but it's a common trick for this type of problem in which we'll end up telescoping. Let's go ahead and rewrite that one in the numerator using terms from the denominator. So what I mean by that is, for example, let's maybe rewrite this one. First of all, let me go ahead and multiply this by 4, and I'll make up for it by dividing by 4. Now I'll rewrite this 4 as n plus 2 minus n minus 2. These are both terms from the denominator. We can see that n plus 2, n minus 2. So we'll see in a second why this works out. And then we still have that 1 over 4, so let's just write it over here. The next step after we write this denominator will be to just split up the fractions. So this is just the sum. So 1 over 4 sum 3 to infinity. Then we have n plus 2. That's the first fraction. We have one more to write, so we will have to write that denominator again. This time n minus 2 up top. And you can see in both fractions we will get some cancellation. This is why it's important to make sure you're choosing terms from the denominator up here. And this step right here, both of those terms came from the denominator. And this was what is allowing the cancellation to happen. So if you don't use those terms, you most likely won't get cancellation. Here we cancel the n plus 2's. There, cancel the n minus 2's. Now let's just go on to the next page to rewrite this. We have 1/4 sum 3 to infinity. And then we just have the first fraction after we canceled. And the second, 1 up top. And then in the denominator, n minus 1, n plus 1. And then n plus 2. So now let's just put parentheses around this to make sure we're adding the whole thing is inside the sum. Now we should rewrite this as a limit. This is telescoping. Notice that as you increase n to n plus 1, that the denominator on the left turns into the denominator on the right. So here we will have lots of cancellation. This is the perfect time to do telescoping. So if we'll do telescoping, we should rewrite this infinite sum as a limit of partial sum. So let's write it as the limit as k goes to infinity of the partial sum from 3 to k. Now we'll go ahead and just one more time write down these two fractions, and then we're ready to telescope. So n minus 2, n minus 1, and n plus 1. Second fraction, 1 over n minus 1, n plus 1, n plus 2. Now let's go ahead and evaluate. So let's ignore the limit for a moment. We'll rewrite that limit. We're just simplifying everything inside the limit. So everything in these large parentheses, including the sum. So let's go ahead and evaluate that sum. So plug in n equals 3, your starting point, and try to be as careful as you can here. So we'll have 1 times 2 times 3 times 4 minus 1 over 2 times 3 times 4 times 5. That's the first term. Then you increase n by 1, so now you plug in 4. And you can see already we'll have some cancellation. Lots of cancellation here. If I were to write the next term, and once again, I can see cancellation here. So everything will be canceling out, and then we'll keep adding in the other direction. And then we'll have, it looks like I'm getting a little low here on room. But when we get to the very end, so here you may want to keep track of this. You could pause the screen, but I will have to include the last few parts here of the sum on the next page. So going on to the next page, I will keep adding, and then I have 1 over k minus 3, k minus 2, k minus 1, k minus 1 over k minus 2, k minus 1, k plus 1. And then one more term after that, the very last term, when you plug in n equals k down here. And we could see once again cancellation, and then we're left with the very last term. And so here, k minus 1, k plus 1, k plus 2. Then everything that except the very first term and the last term would have canceled. So remember, this whole time we had pulled up the limit in the 1 over 4 on the previous page. So we have 1 over 4 limit, k goes to infinity. After cancellation, all we're left with is 1, 2, 3, 4 over here. And then we subtract k minus 1, k plus 1, k plus 2. Take that limit as k goes to infinity. The second fraction will go to 0 because the denominator goes to infinity, but the numerator is fixed at 1. And then you just have 1 over 4 times 1 over 1 times 2 times 3 times 4. So we would have to simplify this, and that is just 1 divided by 96. And that's our final answer.